Welcome to Chapter 6, Network Security Basics. How do we shield our networks from relentless attacks? By mastering the core tools and tactics. Safeguard your network traffic, shrink your vulnerability. These skills are a must for every computer science pro. Protect your digital domain with precision. How do you fortify your network? Let's dive in. Welcome to Chapter 1, where we dive into essential cybersecurity technologies. Firewalls, learn how to filter traffic and control network access. Virtual private networks, create secure tunnels over public networks. DDoS attacks, understand devastating traffic floods. Mutual TLS, implement two-way authentication. Zero Trust Security, verify every request in modern networks. By the chapter's end, see how these technologies interplay to form a robust security strategy. From firewalls to zero trust, this chapter will equip you with crucial tools and insights for safeguarding your digital assets. Imagine your network as a fortress, with the firewall standing guard at the entrance. It's the first line of defense, scrutinizing every incoming visitor like a vigilant security guard at a building entrance. Only those with the proper credentials can pass through. Firewalls are crucial in safeguarding your digital domain. Ever wonder how firewalls work their magic to keep your network secure? They meticulously analyze each data packet, scrutinizing source and destination IP addresses, port numbers, protocols, content, and even connection history. Network administrators craft access control rules, dictating what traffic is permissible, from services accessible to who can access them and under what conditions. These modern guardians can function at various network layers, from basic packet filtering to in-depth scrutiny of application-level data. Think of firewalls as vigilant gatekeepers, safeguarding your digital realm with precision and vigilance. What types of firewalls are out there, and how do they defend our networks? Let's start with packet filtering firewalls. These are the basic guards, quickly sifting through packets based on IP addresses, ports, and protocols. They're speedy but can miss complex threats. Moving on to stateful firewalls, these take a smarter approach by tracking entire connections and patterns. They remember past packets to catch suspicious activity across requests. And then, we have the next-gen firewalls, the superheroes of the bunch. They blend classic filtering with deep packet inspection, intrusion prevention, and app awareness. Think of them as the ultimate security detail, pinpointing and shutting down specific threats. Firewalls come in all shapes and sizes, each playing a crucial role in safeguarding our digital world. Remember, the key is to match the right firewall to the right task. Ever wondered about the stark contrast between a secure and insecure network? Picture a network without a firewall, all ports laid bare to the internet, inviting attackers to probe for weaknesses and exploit vulnerabilities at will. But introduce a firewall into the equation, and suddenly, only authorized traffic gains entry. Malicious attempts are swiftly thwarted, internal services remain hidden, and your attack surface shrinks significantly. In the battle for network security, the firewall emerges as your stalwart shield, safeguarding your digital domain with unwavering vigilance. Imagine driving on a private highway through a bustling city. That's the power of a virtual private network, or VPN. It creates a shielded tunnel through the internet, encrypting your data for secure transmission. Your online activity remains private and protected, even amidst the chaos of public networks. With a VPN, you control your digital journey, safeguarding your information from prying eyes. It's like having a secret passage in a crowded street. Your data stays yours, secluded and secure. Ever wonder how VPNs create those secure tunnels? It's like a digital cloak of invisibility. Your data, encrypted at your device, becomes gibberish to any prying eyes on the public internet. Then, the VPN server plays the hero, decrypting and forwarding your traffic safely. Finally, your request arrives at its destination, seamlessly blending in as if local. It's all done in milliseconds, behind the scenes, shielding your online activities. VPNs, your invisible shield in the digital world. Ever wondered how organizations ensure secure remote access for their employees? With VPNs, it's possible. Employees can work from home, coffee shops, or airports without risking sensitive data on public Wi-Fi. How? By encrypting all traffic with top-notch algorithms, shielding against eavesdropping and attacks. Furthermore, VPNs cloak internal IP addresses and network layout, thwarting attackers from probing your infrastructure. In a digital world fraught with risks, VPNs offer a robust shield for organizations, ensuring data security and privacy in a seamless, invisible manner. Takeaway: VPNs fortify organizational security by encrypting data and anonymizing network details. Imagine you're at a bustling coffee shop, focused on a critical project. But beware, the unencrypted public Wi-Fi leaves your data vulnerable to prying eyes. What can you do? Simply connect, launch your company's VPN, and voila, a secure tunnel to your office is created. Now, work with peace of mind, shielded from potential threats. Stay vigilant, even in seemingly safe spaces. Ever wonder how a website can suddenly go offline? Enter distributed denial of service attacks, or DDoS for short. Picture this: a flood of internet traffic bombarding a target from multiple sources at once. The aim? Not to steal data, but to overpower services with an onslaught of requests. It's like a digital traffic jam that brings everything to a screeching halt. Imagine your favorite website suddenly swarmed by thousands of fake users, rendering it unreachable. DDoS attacks are not about theft but disruption, causing chaos in the online world. Ever wondered how DDoS attacks manage to bring down websites and servers? It all starts with assembling a botnet, a network of infected computers controlled by attackers. With a single command, these compromised devices flood the target with traffic, overwhelming it and causing service disruptions. Imagine millions of requests bombarding a server, leading to a complete shutdown, costing money, and tarnishing reputations. This coordinated attack not only consumes resources but also blocks out legitimate users. In the world of cyber warfare, a well-orchestrated DDoS attack can spell disaster for online operations. Did you know that 67% of companies report significant revenue impact during downtime caused by DDoS attacks? This translates to a loss in customer trust, with 54% experiencing decreased confidence after an attack. The average cost per hour of downtime for medium-sized businesses is a staggering $120,000. Beyond immediate financial losses, DDoS attacks can severely damage brand reputation and serve as a smokescreen for other malicious activities, such as data breaches. These attacks are not just about money, they erode trust and credibility. Ever wondered how to defend against a DDoS attack? Here are some strategic approaches. Monitor traffic patterns to differentiate real users from bots. Implement rate limiting to control requests from a single source. Utilize CDN protection to spread traffic load across servers. And don't forget black hole routing, a way to block malicious traffic before it reaches your network. These strategies form a robust defense against cyber threats. By analyzing, limiting, distributing, and blocking, you can stay ahead of potential attacks. Remember, a well-prepared defense is key in the ever-evolving digital landscape. Ever wondered how secure your online transactions really are? Traditional TLS does a decent job, but Mutual TLS takes security to the next level. With Mutual TLS, both client and server authenticate each other using digital certificates. It's like a high-security facility where everyone shows their ID. This extra layer of verification ensures airtight security. Mutual TLS, raising the bar for online safety. Ever wondered how secure connections are established online? Enter MTLS, the powerhouse of two-way authentication. It all starts with the client hello, where the client lays out its encryption methods. The server then flexes its authenticity muscle by presenting its certificate for verification. Not to be outdone, the client steps up with its own certificate and proves its identity. Once both sides are in the clear, an impenetrable encrypted channel is born, thanks to those trusty session keys. In the world of online security, MTLS is the ultimate gatekeeper, ensuring only the verified can pass through. In a world of interconnected systems, when should you turn to MTLS for security? In the realm of microservices architecture, MTLS ensures each service authentically communicates. For safeguarding vital APIs, like those handling financial transactions, MTLS is crucial. And in IoT device networks, MTLS secures against unauthorized access and compromised devices. Yes, MTLS introduces complexity, but it offers paramount assurance that both endpoints are truly who they claim to be. In high-security settings, this authentication is indispensable. So, when security is paramount, MTLS stands as a safeguard against potential threats. In the world of cybersecurity, trust is a liability. Never trust, always verify. This mantra encapsulates the essence of zero-trust security. Gone are the days of relying on a perimeter defense. In this landscape, threats lurk inside and outside the network. Picture your data as a precious gem, surrounded by layers of defenses that scrutinize every entity that seeks access. Suspicion is the norm, validation the gatekeeper. Zero trust is a paradigm shift, a mindset that challenges assumptions and embraces vigilance. It's a new era where every attempt to breach is met with scrutiny, every access request subject to relentless verification. Trust no one, validate everything. In the world of cybersecurity, zero-trust principles are a game-changer. Imagine this: every access attempt, regardless of its origin, is rigorously authenticated and authorized. No automatic trust based on location or network membership. Users and services are granted only the precise permissions required for their tasks, with access expiring and needing regular renewal. Assume the worst, design systems as if attackers are already inside, segment networks to limit damage. Continuously monitor and analyze behavior in real time, swiftly responding to any suspicious activity. In a zero-trust environment, verification, least privilege, breach assumption, and continuous monitoring are not just concepts, they're proactive safeguards against potential threats. Remember, stay vigilant, stay secure. How can we build a security-first mindset in today's digital landscape? By layering our defenses with firewalls, VPNs, and MTLS working in unison. Understanding DDoS attacks is key to fortifying our systems against unexpected surges. In the world of modern architectures, trust is earned, not assumed. Zero-trust principles are paramount. Ready to put theory into practice? Dive into lab exercises, configuring firewalls, setting up VPN connections, and implementing zero-trust policies. Security isn't a one-size-fits-all solution, it's a dynamic, multi-layered approach. Remember, in a world of evolving threats, vigilance is key.